Hey everyone, welcome to the recap video for MTRW on April 20th. So today's lecture was about the homework. Then we talked about lessons 165 through 166. And then we talked a little bit about solving inequalities. Okay, so without further ado, I'm going to jump into the homework. So I saw a lot of mistakes in exercise number 5, lesson 161, because it basically made you do questions that had a little bit of every operation with negative signs, and there were lots of opportunities to make mistakes. So I'm going to just talk about part C in number 5 as just one example. Okay, so the first mistake that I saw is that a lot of folks interpreted the minus sign in front of the 7.2, so this guy, not as subtraction, but rather as multiplying 7.2 to all these other things around it. That's not the case. This is actually just subtraction. Okay? And with these types of questions, they're usually just two strategies. I'll just write them down. The first one is always tried and true. It's PEMDAS. So parentheses, exponents, multiplication, division, addition, subtraction. And the second is to use the distributive property. This lets you get rid of some of the parentheses. Distributive. So what that would look like is you take this minus 8 and you distribute it to the minus 13 and the plus 7 and so on. And sometimes that helps you because terms will cancel out. In this case, it's not going to help us too much. We're just going to stick with PEMDAS. So for this, we're going to just do PEMDAS. And it says parentheses first. Okay, so parentheses, there are two sets of them that we can do at the same time. This minus 8 we don't touch. And then we have minus 13 plus 7, which is minus 6. The minus 7.2 we don't touch. And then we have minus 1.2 plus 8.8, which is minus 10. I saw a bunch of mistakes with this calculation too. I saw a bunch of 1.2 minus 8.8, which gets you a much harder number to work with. Just be extra careful even when you're doing things like addition and subtraction. Sign errors still come up left and right. Okay, so next up in PEMDAS is multiplication and division. So I have two sets of multiplication that I can do at the same time. So the first set, I'm going to do these two. That's positive 48. And then we subtract 7.2 times minus 10, which is minus 72. So here we have to be really careful. I move the subtraction sign down, so I can just treat this as positive 7.2 times minus 10. Okay? And now I'm going to have 48 plus 72 because I'm subtracting a negative number here. I saw a lot of 48 minus 72s also at this step, and you guys got so close, but ultimately the answer wasn't correct. But if we did stay careful, we have 120 as our final answer. Cool. So the moral of the homework, let me just write that down. Of the homework is to double check your signs. Every time we do an addition, a subtraction, a multiplication, a division, signs will be involved. And this expression, for instance, in part C, we had so many different operations we were doing. We had subtractions, we had multiplications, and all that. And every single one of these operations is an opportunity to make mistakes. So we want to just be extra sure every time. Another tip is to not simplify too much at once. I know a lot of you guys want to get simple steps, like combine them, do less work. But when you do that, you're also making yourself more likely to make errors. Okay, the next homework question we talked about was exercise number 6, and this was in lesson 160. So this question was a lot of fun. The general gist was they gave you 4 numbers multiplied together, and you had to compare the product with 0. And what does comparing the product with 0 mean? It just means, is the product greater than 0, less than 0, or equal to 0? Oh, I didn't write the 0. And it turns out that there's a really nice way to do this. So if your number is greater than 0, that just means it's positive. And if your number is less than 0, that just means it's negative. So really, we just need to check the sign of the product. We don't even have to actually compute the number value of the product. We just have to check the sign. So an example is question B, where we had a negative number, then a negative number, then a positive number, and then a negative number. So what I wanted to see for this question is that, okay, we can first simplify these 2 negatives. They make a positive. So we have a positive, then a negative. And then we have these 2 positives that we can combine to another positive, then a negative. And all together, we get something that's negative. Another way to just easily check is to count how many negative signs there are, and if there are an even number of negative signs, then our answer will be positive, because the negative signs cancel out in pairs. If there are an odd number of negative signs, then our answer will be negative. And we also noted in class, that the product equals 0 only if at least one factor equals 0. So if you have a bunch of factors that are all non-zero, you're always going to get something that's either strictly positive or strictly negative. Okay, so I'm going to zoom out of this page. Now is a good time to pause the video and recap this if you want to think about the homework again. Okay. If that looks good to you, we're going to move on to lesson 165. And lesson 165 concerns equations with rationals. Lesson 166 is actually kind of a review lecture. So if you're studying for the final, that's a good one to look at. At least look at those problems and see if you can do them. So lesson 165 introduces, let me draw that better, 3 types of equations. Okay, so type 1, I'm going to use x as my variable and a and b as placeholders for numbers. So type 1 is a times x is equal to b. So here a and b are rational. And we saw that this is really similar to just equations with integer a and b. We're going to just divide both sides by a and solve for x this way. X is equal to b over a. Okay? Well, one thing we need to be careful about now, though, is to pay attention to the signs of a and b. Cool. Next up is type 2. okay? And this is the type that is x divided by a is equal to b. Slightly different from type 1. This one also looks a lot like equations we've seen before. To isolate x by itself, we're going to multiply both sides by a. So this will get us x is equal to a times b. So we get a different solution format as well. Okay? And the last type of equation they talk about is type 3. This is the trickiest one. This is the type a divided by x is equal to b. So here, I'm going to just rewrite this as fraction. A over x equals b. I like writing things as fractions instead of using this division sign because it's a lot more clear what's going on. Like now I can very clearly see, x is in the denominator. And that's a problem because when we solve for x, we eventually want it in the numerator. So this is telling us we need to get x into that numerator as soon as possible. So this tells us now a is equal to b times x. And after this point, we finally get something that looks familiar. Now x is equal to a over b. So I wanted to point out these equation types because in the past I see often a lot of mistakes that mix these two types up or mix these two types up. This is really telling us, hey, when we start with an equation, oops, did not mean to erase that. When we start with an equation, we have to be very cognizant, we have to be very aware of what's going on with x. Does it start off in the numerator or the denominator? Is stuff being multiplied to it or being divided from it? So actually, I talked about this in class, but I recommend that when solving here, when solving for x, we want to actually go through all steps. So things like here where we have to multiply both by x and then divide by b, show all that. You're less likely to make mistakes. Also, do not just memorize. The types are kind of a nice way to show that there are so many different ways x can interact with other numbers in your equations, but don't just memorize these because that's not the most foolproof way to go. Okay, so at this point in the class, we took some time to have everyone try lesson 165, numbers 1D, number 3C, and number 5B. So if you're following along at home, now is a good time to pause the video and try these yourself. Okay. This next page, I'm going to go over all of those questions. This is lesson 165. Okay, first 1D. I have to solve this equation x times minus 5 equals 2. So if we want to jump back to our previous page, this is a type 1 equation. So if you have these notes and you want to just double check yourself, that's a way to go, where this guy is A and this one is B. Okay. To solve this, we're going to have to divide both sides by minus 5. This is where things get tricky because now signs are involved. So now we have x is equal to 2/5 in number, but we have to carry on a minus sign. And similarly, so I think I made a mistake in the notes that I wrote in class. Someone should have caught me. But make sure you fix that in your own notes. The second part of the question is x times minus 5 is equal to minus 2. We're literally going to do the same steps. There's only one step here, same step. But because we started off with minus 2 on the right instead of 2, the only thing that's going to change is our sign. So we're going to end up getting x equals 2/5. Nice. Okay. Next, we're going to do 3c. So 3c looks slightly different. We have x divided by 5 now. So it's just 5, no sign. Equals 1.4. Cool. This, if you're following along with the previous page, is a type 2 equation. Okay. So in this case, this was A, this was B. To solve this, we're going to have to multiply both sides by 5. So now we have just x on the left-hand side, which is what we want. And on the right-hand side, we have 1.4 times 5, which is 7. And again, there's a second part of this question that's x divided by 5 is equal to minus 1.4. Again, it's the same step. So we end up with x is equal to minus 7. The only thing that's changed is this minus sign in front of the 1.4. Last but certainly not least, let me draw that better, is 5b, where we have minus 3 divided by x is equal to 5. Oops, I should have written that in white. This is a type 3 equation. And an easy way to identify that is because x is being divided. If we wrote this as a fraction, it would show up in the denominator. So we want to move this to the numerator as soon as possible. We're going to multiply both sides by x first. So now we have minus 3 is equal to 5 times x. And then dividing both sides by 5, we get x is equal to minus 3.5. Watch out for those signs. And it's the same story when we look at the second part of the question. We have minus 3 divided by x is equal to minus 5. So in this case, we're still going to use the same steps. Well, actually, not even the same steps. We're going to still multiply both sides by x. So now we have minus 3 is equal to minus 5 times x. Now I have to divide both sides by minus 5. So I get x is equal to 3/5. Cool. I'm going to zoom out on just these 3 questions. These are pretty good examples of seeing a variety of signs in play and seeing a variety of equation types in play. So now is a good time to pause the video if you want to take a further look at these questions. Cool. So for the last 10 minutes of class, we talked about solving inequalities. So this is something that I think is really good to know, especially if you haven't learned it yet. It's something good to keep in mind because you're going to learn it very soon in school if you haven't already. So solving inequalities, this is not going to be on the final. This is something we have to pay attention to. So a lot of times you're going to get questions like, find x, or which x, find x that, / which values of x, satisfy an inequality and not an equation. Equations we know how to solve, but inequalities we haven't talked about. Let's say I want to know x is such that 2x plus 5 is greater than 7. Okay, well, one thing I can do is I can kind of guess and check. So maybe I'll guess x equals 0 because, why not? Let's start there. And I have 2 times 0 plus 5. Oops, that's 5. That's not bigger than 7. So, okay, 0 doesn't work. But now it seems like, we can go bigger. So I can try 10, x equals 10, and that will work. I can also try x equals 100, and that will work. But this doesn't really actually answer the question, what are all the values of x where this works? So in order to answer that question, we have to solve the inequality. And solving the inequality will look a lot like solving the equation if this were an equal sign instead of an inequality. So I'm allowed to subtract 5 from both sides of the inequality. So then I'll get 2x is greater than 2. And then if I were doing this to an equation, I would divide both sides by 2 again, and I'll have x is greater than 1. And if we want to double check ourselves, I can choose some x that's greater than 1. Let's say x equals 4. And I can check that this inequality is true. So it sounds like so far there are a couple things that we can do. So we can add or subtract the same number from both sides of an inequality. And we can also multiply and divide, it seems. But we have to be really careful. We can only do this directly with positive numbers. Hold on. And let's see what happens with a negative number. So let's ask the same question. Except minus 2x plus 5 now is greater than 7. Okay, well, as before, we know that this is fine. We can subtract 5 from both sides. We're going to get minus 2x is greater than 2. And now what I want to do is I want to divide both sides by minus 2. I mean, I have to isolate x somehow. But if I write x is greater than minus 1 in this case, I could totally plug in x equals 0, and that's not going to work. What went wrong here? Well, it turns out that for inequalities, when you multiply both sides by a negative number or divide both sides by a negative number, you have to flip the inequality. So instead of being x greater than, we have x less than. And we still do this division as usual. As an exercise, I want you guys to pick some values of x that are less than minus 1 and plug them into your inequality and check if it works out. So the last thing we need to note is if we multiply or divide by the same negative number on both sides, we have to flip the inequality. This is another thing that you have to be extra careful about. And if you want to see why we flip the inequality, we have that worksheet from last week and the week before, where it goes through why the inequality has to flip. We go through an example where we multiply both sides of an inequality by a positive and a negative number, and we look at the number lines. Okay? So if you want more information about that, check out the worksheet again. I'll zoom out so you can summarize this page. Cool, that's it for today. Remember that next week you'll be receiving the final, and it'll be due as homework. Great, thank you.